Hey, welcome everybody to 9.3, Graphing General Rational Functions. So this is going to be similar to section 9.2, only the things we're going to be graphing are more difficult. You can see a warm-up at the top of your page. Please pause the video and try to solve for x in each of these situations, and I'll give you a hint. Factor method is the hint. Alright, if you have unpaused, you can go through here and look at the answers. So as you can see, all I did was factor, and then I took each parentheses and set it equal to 0 and solved it. Alright, so let's give you a bunch of information about how to graph the functions that we will be graphing today. Here's the general format for our graphs. Our function today is going to be in fraction form, and there will be a polynomial on top and a polynomial on bottom. And review from Geometry 2, a polynomial is just a mathematical statement with x's and any variables and coefficients and plus or minus signs in between. Just a quick comment. The numerator is the top and the denominator is the bottom. So if you hear me say those words, that's what I mean. And then when I'm looking at my polynomials, we'll be looking for something called the degree. And the degree of a polynomial is the largest or the highest exponent that you see. And for the ones that we're going to do today, they're simple. So for example, let's say I had the polynomial 4x cubed plus 2x squared minus 4 or something like that. This one has a degree of 3. So the highest power exponent is going to be the degree for the ones we're working with today. Alright, so here's some information for you, and we'll use the degree in just a little bit in case you're wondering why I did it. Alright, x-intercepts. The x-intercepts are where the numerator, or I'm going to say p of x from our formula, is equal to 0. So basically we're going to find the zeros or the solutions of the top part of the fraction for the x-intercepts. So where the p of x or the top is equal to 0. Vertical asymptotes happen where q of x or the bottom, the denominator, is equal to 0. So basically, and when I say zeros, same thing as solutions. So basically the zeros of the bottom. So we're going to be doing a bunch of factoring today. Almost every single time we're going to have to factor the top or the bottom, sometimes both. Sometimes you won't have to factor either one. Last piece of information for you. This one's kind of complicated, so make sure you write this down very carefully. The horizontal asymptotes. And one thing I want to comment on really quick. Let's pretend that for my polynomial statement, on top I have an m degree. On top I'm going to say has a m degree polynomial, and on bottom I'm going to say it has a n degree polynomial. So there's two things. If the top polynomial degree is less than the bottom, so the top degree is less than the bottom degree, then y equals 0 is the asymptote. So every single time the top degree is less than the bottom degree, y equals 0 is the asymptote. Second piece of information, if the top degree is equal to the bottom degree, so the top is equal to the bottom, then y equals a over b is the asymptote. And when I say a over b came from the polynomials, and they're the very front coefficients, or the coefficients of the highest power term. So a and b just stand for the coefficients of the two polynomials. Okay, last but not least, if I look at the degrees of the polynomial and the top is greater than the bottom, there is no horizontal asymptote. Now, I'm just going to throw it out there. This takes a while to memorize. So I'm thinking every single time we graph, we're going to be referring back to this and referring back to this and referring back to this, and do that when you do your homework too, because it takes a while to get the hang of this. All right, so we're going to do a few, or actually two, of each type of these horizontal asymptote ones, starting with the denominator having a greater degree. Here's what I mean. If you look at this first statement I got, y equals 4 over x squared plus 1, if there is no x value at all, it's actually considered a degree of 0. So if there's no x value at all, it's considered a degree of 0. And then the bottom obviously has an x squared, so that one is a degree of 2. That is why I would say the top degree is smaller than the bottom degree. So this is a m is less than n situation. Okay, so here's what that means for me. And you know what? I should backtrack a second. I found my degrees. What I want to do to start my graph is I want to figure out where my x-intercepts are, where my horizontal asymptotes and vertical asymptotes are, and graph those all in, and then I'm going to base my graph off of that. So I just figured out that my top degree is less than my bottom degree. I'm going to go back to my notes. Okay, if the top is less than the bottom, then y equals 0 is the asymptote. Okay, so my horizontal asymptote is y equals 0. I'm going to go ahead and draw that in. So y equals 0 is my horizontal asymptote. Then let's find my other information. So my x-intercepts, back to what I looked at in my notes, it said where the solutions of the top. And I want to tell you that if there is, or basically it's kind of like what value could you plug in and make it a 0 for the bottom one. But anyways, for the top, there's nothing I can plug in that would make it a solution. I mean, there's no variable at all. So that means that there's no x-intercept. And that also makes sense because I just drew my asymptote there, and we know that our graph cannot touch our asymptote. Next, vertical asymptotes. All right, so that's where if I go back to my notes, that's the zeros of the bottom, or if zeros is confusing you, you should write the solutions. So when I look at x squared plus 1, I want to try to solve this. And now, hold on, trick question. Usually at this point, if I have an x squared, you would factor it, right? But hopefully we've talked about this in class. If I've got x squared plus 1, it can't be factored. X squared minus 1 could be factored, but x squared plus 1 can't be factored. So what that means is there are no vertical asymptotes. I can't solve that. It would be imaginary. So no vertical asymptotes. All right, now here's what we're going to do. I want you to find 2 specific points in every area of your graph, and then we're going to just draw on the curve. Now for this particular graph, there's not different areas. All we've got is one long graph. You'll see in a second what I mean. So I'm going to actually find more than 2 points. But at this stage, I could use my calculator to find a table of values if I wanted to. I just got to remember that if I'm going to plug in my y equals, I have to put the stuff with the plus or minus sign in parentheses. Alright, so to find my y value, I'm either looking at my table of values, or I am going to go ahead and plug in my x value and solve. So I end up with negative 2 comma 4/5 for the first point. And I end up with negative 1 comma 2 for the second point. I end up with 0.4 for the third point. Okay, and 1 comma 2 for the fourth point, and I'm almost done. And again, I'm just plugging everything in and finding a table of values. Okay, there we are. Now, just to throw it out there, all the graphs we're doing today are going to look like nothing you've ever graphed before. They're all going to be totally new. So once you get a few specific points, and when I say 2 in each area, that will make more sense when I get to the next example. But in this situation, and then once I get my points, sketch in your curve. So in this situation, there's no breaks in the graph. So technically, I could have just done 2 dots total and just drawn in the curve. It's good to do more to be more specific. Again, as soon as I do example B, I'll show you what I mean by different regions of the graph. All right, anyways, let's find the domain and range. Remember, domain is x's, range is y's. When I look at my x's, remember I'm looking for where is there a starting or stopping point? Is there a break in the graph anywhere? There's not for the x's. So the x values are all the reals. Any number works for x. Any number I could plug in. And if you look at the y's, there's only going to be y values greater than 0. And there's kind of a maximum as well, but usually we would just say y is greater than 0. We wouldn't try to figure out what that maximum was. Once you go ahead and pause if needed, but once you're done, look at the next graph, and let's do this one. So this time, on top, I've got a 2x, and 2x is really like 2x to the first, so the top has a degree of 1. The bottom, again, has x squared, so that's a degree of 2. All right, so I just figured out that top degree is less than the bottom degree. So when I'm trying to do my first step, which is find all my asymptotes, I know I can look at my note sheet, top is less than the bottom. Okay. Top is less than the bottom. That means y equals 0 is my horizontal asymptote. Awesome. There I go. Y equals 0. Then let's go ahead and find our x-intercepts and our vertical asymptotes. All right, so x-intercepts. Again, I'm trying to find the solutions or the zeros of the top, and the top is 2x. So what that means is I'm going to take the top, set it equal to 0, and solve it. So when I go ahead and solve this, I end up with 0 over 2, which is 0. So x equals 0 is going to be an x-intercept. So that's actually a point on my graph. And I just possibly did something wrong here. All right, it looks like this graph, I just have a x-intercept that actually goes over my asymptote, which is not supposed to happen, but it is. So I'll have to take a look at that and get back to you later about that one. We're just going to keep going though. So to find my vertical asymptotes, my bottom is x squared plus 8x plus 12. So I'm going to set that equal to 0, and now I'm going to find the zeros of that. So in your mind, you're thinking factoring. And then I'm going to solve it. So x equals -6 and x equals -2 are the two solutions. Those are where my two vertical asymptotes are going to go. So there I go, x equals -2. 3, 4, 5. And here I go, x equals -6. All right. So now it's a little bit more clear to you what I meant by different regions. So I'm going to have some graph area here in this area. I'm going to have some graph area here, and I'm going to have some graph area here. So in each one of those 3 sections, I want to have you graph 2 points. And then after you graph your 2 specific points, you can just draw in the curve. So first I'm going to do this region over here. So I need dots that are to the left of this asymptote. So that could be, for example, -8 and -7. And now you are allowed to use your calculator, but once again, if you're typing this in, it's so important that you don't forget to put those parentheses around this stuff. So if I'm going to try to type that into y equals to get my table, or if I'm just plugging in -8 to solve it, put your parentheses there. Just to save some time, because this video is going to probably go kind of long anyways, since this is a hard topic. If you'll just trust me on this, I did these ahead of time, so I've got some of the points made already. So when I plug in -8 for x, I ended up with -1.3 for y. And when I plugged in -7, I ended up with -2.8. So I'm going to try to graph those 2 dots. So -8, -1.3, and then -7, -2.8. All right. That's my first kind of region. In the middle region here, I could pick, let's see here, 1, 2, there's x is -3, x is -4, x is -5. So I could take any of those 2 points. So maybe we'll do -5 and -4. So when x is -5, my answer is 3.33. When x is -4, my answer is 2. So 1, 2, 3, 4, -5. 3.33 and -4, 2. All right, and last but not least, I'll do this region here. I already have my x-intercept going on. So why don't I do -1 and 1 maybe? I already figured out my x-intercept was at 0, 0. Alright, so when I plugged in -1, I got -0.4, and when I plugged in 1, I got 0.1. So -1, -0.4, and 1, comma, 0.1. Alright, let me just show you really quick what I mean when I say to plug it in with parentheses. So here is me going ahead and plugging this into my calculator. Okay, if I look at my table of values, I should get the same things that I just was saying earlier. And you can see I have error messages at my vertical asymptotes. Alright, once I get my 2 specific dots, or 2 or more in each one of the regions, look at your graph and just sketch it in. And I want to tell you that our calculators are very unsophisticated, so our calculator is unable to lift up its pencil. So when you look at this, it's kind of like your calculator just drew it in, and then it's like an Etch-a-Sketch, right? Remember those Etch-a-Sketches? It can't lift up its pencil, so in order to get to this next spot, it had to draw this line, but that line shouldn't really be there. So I'm going to try to sketch in this picture, and using my dots I made. Again, do the best, but use your specific dots you made as a guide, and then there's what my graph looks like. Alright, once you have that, flip to the back. Oh, I forgot domain and range. Okay, domain. I have all reals except -6 and -2, because that's where my 2 asymptotes are. And then my range are all reals. Now, again, it might be all reals except y equals 0, but that is working right now. So again, I'll get back to you on that one. Alright, flip to the back side. Alright, so now we're going to graph when the degree of the top and the degree of the bottom are equal. So if you look at this first one here, obviously both of them are x squared. So that's what I mean by degree of top and degree of bottom are equal. Alright, so let's go through and find our x-intercept, horizontal asymptotes, vertical asymptotes. So, first of all, degree of the top and the bottom are equal, so that means for my horizontal asymptotes, it's the y equals a over b, which remember just means the coefficients of my 2 polynomials. And if there's nothing in front here, it's like a 1. So here my asymptote is at 3 over 1 or at 3. So there I go, y equals 3 for my horizontal asymptote. My x-intercepts are at where the top is equal to 0. And now 3x squared equals 0, solve it. You go through here and you just end up with 0. So my x-intercept is 0 again. To find the vertical asymptotes, I'm going to solve the bottom. So I got x squared minus 4 equals 0. And when you, if it can be factored, I go for it. So x plus 2, x minus 2 equals 0. X equals -2, and x equals +2. So my 2 vertical asymptotes are at 2 and -2. Alright, so as you can see, I again have, if I think about it in the regions split vertically, I've got a region here, a region here, and a region here. So there's 3 different regions where I want 2 points of each. And again, you are allowed to use your calculator. So let's suppose that I'm going to go ahead and type this in. Once again, remembering that when I go into my y equals, I want to put the top one in parentheses. So I got 3x squared there. And then I've got x squared minus 4 for the bottom one. There I go. So let's go to the table of values. And I want, again, 2 points in each one of these kind of areas. And you can see the error messages where our asymptotes are. So let's say I'm going to use -4, 4 and -3, 5.4 for my table of values. So -4, 4, -3, 5.4. There I go. For the next region, how about we use, let's use -1 and 1 since I already have my x-intercept plotted there. So here are those 2 points. And in my third region, on this side of the error sign, I've got, let's use 3 and 4. So 3 is 5.4 again, and 4 is at 4. So 3 comma 5.4, and then 4 comma 4. And you can see this one kind of mirrors itself actually. Let's look at the picture and then we'll sketch it in. So again, remember your calculator is just not capable of picking up its pencil, so but those are, they're kind of like the asymptotes really. So I've got one here, I've got a part of my graph here, and I've got another part of my graph there. Alright, domain and range. So where the x's are, domain can be all reals except x equals -2 and x equals 2, and then the range is all reals except y equals 3, where my asymptotes are. Just for time's sake, I'm not going to do this second graph here. If you want to come in class and copy my notes and see how I did it, you can, or you could pause and try it on your own right now, your choice. I'm going to move right along though to this next type of thing down here, and this is where the degree of the numerator is greater than the degree of the denominator. And I'm going to do this one right here on the right side. Okay, so if you notice, the top degree here is x squared, so at 2, and the bottom degree is a 1 because it's just regular x, which is like x to the first. So that's why I'm saying the degree of the top is greater than the degree of the bottom. Alright, so if I look back on my notes sheet, this is the easy one. If the degree of the top is greater than the degree of the bottom, there are no horizontal asymptotes. So I get to just jump right in with the other part of it. So for my x-intercepts, I want to figure out where the top is equal to 0. So I'm solving this equation, and when I solve it, I get x minus 4x plus 1 for my first step when I factor it. So my two x-intercepts are at 4 and -1. Okay, there I go. So that's kind of ready to fill in with my graph. And then let's find our vertical asymptotes. So again, I'm going to solve the bottom, and this one isn't even an x squared, so I get to just right away just go for it. So my vertical asymptote is going to be at x equals 2. Alright, so this particular time I only actually have 2 regions to worry about when I'm graphing. Let me go ahead and get this all typed into my table of values. And again, I'm using my graphing calculator as a tool. I could create the table of values by hand. I'm just using a calculator because it is faster. Alright, so I got it typed in. So I can kind of see what the graph is going to look like. Let me go to my points. Again, you only need 2 on each side or more. I'm just going to do a few more this time because I can. So how about we do -2, -1.5, 0, 2, and 1, 6 for this region. Okay. And I'm just graphing them, 2, 3, 4, 5, 6. And I had my y-intercept, or x-intercept, sorry, there from before. So now for the other region of my graph, we can do 3, -4. We can do 4, 0. That one's already plotted, right? 5, 2, and 6, 3.5. All right. So again, I'm just going to graph those, 6, 3.5, all right. And I kind of already cheated and looked at the picture early, but it's going to look something like this. And you can tell now why there is no horizontal asymptote. There's no place where my graph stops along the y's. It's just continuous the whole way. And what that also means is that my range this time is going to be all reals, no stopping or starting point, and the domain is all reals except x equals 2. Alright, I'm going to end this video here. Please make a note of things you might want to ask me about, and I'll see you soon. Thanks for listening.